When a quantity y grows and its the growth rate is proportional to the current size, we say that y grows exponentially. Okay, exponential growth is where the rate of growth is dependent on the size of the quantity. The general form that we will be working with for exponential growth is y equals a times b to the x. For exponential growth, b has to be greater than 1. And a is simply the initial size of y. So when x is 0, this thing is just a. And that's the initial size of our y. B determines how fast we're actually growing. A bacteria culture contains 120,000 bacteria. After 7 hours, there are 350,000 bacteria. Determine the size of the bacteria culture after 12 hours. So we are growing exponentially. Bacteria cultures are a classic example of exponential growth, because the more bacteria there are, the more they can split and grow. And so this is an exponential growth model that we're going to be using. So we have y equals a times b to the x. Now, we don't know a lot, but we do know that 120,000 is the initial amount. So that's going to be a. So we automatically know then that we have 120,000 times b to the x. Now, we need to find b first to have our completed model. We know that after 7 hours, there are 350,000 bacteria. So we can plug that in, okay? When our x is 7, y is 350,000. So 350,000 equals 120,000 times b to the 7. And now we can solve for b. So if I divide both sides by 120,000, I get 35 over 12. That's just reducing that fraction a little bit. Equals b to the 7th. Now, to get rid of this exponent, you can think of it in different ways. What I'm going to do is I'm going to raise both sides to an exponent of 1 over 7. And when we do that, we would multiply those exponents and they cancel each other out. And so we just end up with 35 over 12 to the 1/7 is equal to b. Now, we could plug this into a calculator and get a decimal form. I'm just going to leave it in this form for now and take it and plug it back in up here. So we get our model. We get y equals 120,000 times, and then b is 35 over 12 to the 1/7, but b is raised to the x. Okay, so we take that and we raise it to the x. And we can actually simplify that down to well, kind of simplify it, but we have an exponent raised to another exponent, so we multiply those exponents. So 1/7 times x is x over 7. So this is our model, our exponential model. Now that we have our model, we can determine the size of the bacteria culture after 12 hours. We're just plugging 12 in for x now. So y equals 120,000 times 35 over 12 to the 12/7. And now we're ready to plug this into a calculator to actually get a number. Let's go ahead and do that here. So we've got 120,000 times 35 over 12 raised to the 12 over 7. And depending on your calculator, sometimes it'll give you an exact answer like this crazy thing. And sometimes it'll give you an option to approximate it. So you want to use your approximating possibility. And this value is rounded to the nearest whole number in this calculator. Depending on your calculator, it'll round to a certain number. But right now, this is rounding this to the nearest whole number, which makes sense for a bacteria culture. Okay, obviously, we're going to be looking at whole numbers here. So we have 751,848. Okay, and that's going to be our population, or our bacteria size. for this culture after the 12 hours.